Welcome, dear listener, to a journey into the quiet heart of the Amazon, a place where the waters hold secrets, and where one particular creature has long defied our understanding. As the day begins to softly fade, and the world outside prepares for its own gentle slumber, I invite you to settle in, to let your thoughts quiet, and to allow the gentle rhythm of my voice to guide you into a state of deep relaxation. We're going to explore the fascinating, yet deeply calming, story of a fish that holds within its very being the power of a quiet storm. A creature so extraordinary that it reshaped the course of human knowledge and continues to inspire us even today. Imagine for a moment the vast, shimmering expanse of the Amazon rainforest, a tapestry of green and life, where rivers wind like ancient arteries through the land. Deep within these waters, almost hidden from plain sight, dwells a fish unlike any other you might encounter. It's a being of quiet power, a living marvel that, if you were to wade into its domain, would certainly make its presence known in a most unforgettable way. Our story, or at least our conscious human understanding of this creature, truly began to take shape many centuries ago. Picture the year 1773. A time when the world was still vast and largely unexplored, when scientific discovery was an adventure into the unknown. In that year, a remarkable specimen of this very fish made its way across the ocean, from the distant reaches of South America, all the way to the bustling city of Philadelphia. It was an event that stirred great curiosity among the learned minds of the era, for this was no ordinary fish. Those who encountered it, who dared to touch it, quickly observed something truly astonishing. They noted that this creature possessed the extraordinary power of communicating a painful sensation, like that of an electrical shock, to people who touched it, and of killing its prey at a distance. Allow those words to gently resonate for a moment. An extraordinary power. This was a creature that could deliver a jolt, a sudden tingling force that passed from its body into another, a sensation that was both startling and profound. And even more remarkably, it could achieve this feat, this stunning of its prey, not through physical contact, but from a distance, through the very water it inhabited. This was an enigma, a living, breathing mystery that challenged the scientific understanding of the time. How could such a thing be? How could a fish hold within it such an unseen, potent force? This was a fish so profoundly unusual, so fundamentally different from anything previously understood, that its very existence would go on to fundamentally alter the trajectory of scientific inquiry. It would in fact quietly but powerfully change the course of modern society itself, forever influencing our comprehension of the natural world and the unseen forces that govern it. This remarkable animal, which we commonly refer to as the electric eel, is far more than just a peculiar inhabitant of freshwater rivers. It is a living testament to nature's boundless capacity for innovation, and a catalyst for some of humanity's most groundbreaking discoveries. Let's begin by clarifying a small yet interesting detail about our protagonist. While it is universally known as an eel, and certainly possesses the long, sinuous, snake-like form that brings to mind its namesake, this designation is in fact a bit of a misnomer. The electric eel, scientifically speaking, does not belong to the true eel family at all. Instead, it finds its place within the fascinating family of what are known as knifefish, and surprisingly, it shares a closer evolutionary lineage with the humble catfish than it does with the eels we might picture slithering through ocean waters. This subtle distinction only adds to its unique character, setting it apart as a true individual in the vast aquatic kingdom. And while our electric eel is undoubtedly extraordinary, it's worth noting that it isn't the only fish in the world capable of generating electricity. The waters of our planet are home to various electric fish, each with their own specific adaptations for generating and sensing electric fields. However, among all these electrifying creatures, the electric eel stands alone, distinguished by its sheer unbridled power. It is by far the most potent of all electric fish. Some particularly impressive individuals have been recorded delivering shocks that can reach an astonishing 860 volts, coupled with an intensity of 1 amp. To put that into perspective, it's a considerable amount of energy to be channeled through a living organism, a testament to the sophisticated biological machinery housed within its long, powerful body. Now you might be wondering about the impact of such a powerful discharge. What does it feel like? And could it be dangerous? Let's explore this without dwelling on any sense of alarm, but rather with a calm curiosity about the biological mechanics at play. An average shock from an electric eel is a fleeting event, lasting for only about 0.02 of a second. It's a blink and you miss it surge of energy, incredibly swift in its execution. A single shock from one of these magnificent creatures is unlikely to be fatal to a human being, but it could certainly deliver a serious stun. If you were to experience such a jolt, your muscles would momentarily and involuntarily contract, a sudden reflexive tightening, almost as if your body were briefly clenching. Following this instant contraction, you would likely feel a profound numbness, a dull, tingling sensation spreading through the affected area, as your body processes the residual effects of the electrical discharge. However, the real danger, if one were to consider it, would not necessarily come from the shock itself, but from its context. Imagine finding yourself wading through the tranquil, murky waters of a river, perhaps enjoying the quiet solitude of nature, when suddenly you receive such a powerful stun. The immediate effect, that involuntary muscle contraction and subsequent numbness, could leave you disoriented, even momentarily incapacitated. And if you were immersed in water at that precise moment, this sudden loss of control could, in a worst-case scenario, lead to the silent, perilous danger of drowning. It's a powerful reminder of the deep respect due to the wild creatures and the environments they inhabit. The electric eel possesses capabilities that truly border on the incredible. It is one of only a select few animals on Earth that has mastered the extraordinary ability to kill its prey from a distance, a silent, unseen strike delivered through the water. But its electrical prowess extends far beyond mere stunning or killing. Recent discoveries have unveiled an even more sophisticated level of control. The eel can actually use its electricity to remotely manipulate its target. Picture this. The electricity courses through the unsuspecting body of its prey, and in doing so, it compels the prey to act in ways that are ultimately detrimental to itself, and incredibly beneficial to the eel. It's a masterful, almost hypnotic, command over another living organism, a testament to the profound adaptability of nature. And as formidable and ingenious a hunter as an electric eel is when it operates alone, recent studies have brought to light an even more astonishing revelation, challenging long-held scientific assumptions. For many years, researchers believed these eels to be solitary predators, creatures that roamed and hunted independently in their aquatic world. However, the patient, dedicated observation of scientists has now revealed a different truth. Electric eels are, in fact, proficient and remarkably effective pack hunters. They coordinate their movements, ambushing entire schools of fish in terrifying unison, a collective display of power that adds yet another layer to their already astonishing story. This leads us to a fascinating series of questions. Questions that might naturally drift through your mind as you contemplate these incredible creatures. How exactly is it possible for a fish, a living organism, to generate such immense amounts of electricity? And what profound insights has modern science gleaned from studying this improbable, electrifying marvel of nature? Let's delve deeper, allowing these questions to gently guide our exploration. The electric eel makes its home in the labyrinthine network of streams, the seasonally flooded plains, and the slow-moving, often murky swamps that characterize the vast Amazon and Orinoco River basins of South America. This is a habitat that, while rich in life, presents a unique set of challenges, a watery world that can be dangerously seasonal for its inhabitants. During the dry season, for instance, the water levels can recede dramatically, sometimes transforming expansive wetlands into shallow pools and narrow channels. With this reduction in water volume, the availability of oxygen, so vital for aquatic life, can plummet to precarious levels. For many fish, such conditions would spell certain doom. But the electric eel, ever the master of adaptation, has a remarkable trick up its sleeve. It is not solely reliant on the oxygen dissolved in the water. Instead, these incredible fish possess the ability to breathe air, a truly unique adaptation for a fish. This is made possible by a special mucous membrane located within their mouth, a finely tuned biological apparatus that can efficiently absorb oxygen directly from the atmosphere. So, as the waters recede and the oxygen levels dwindle, the electric eel can simply surface, take a gulp of air, and continue to thrive, a testament to its extraordinary resilience and its deep connection to its environment. Let's take a moment to gently paint a picture of what these fascinating creatures look like. As mentioned earlier, they are quite snake-like in their appearance, their bodies long and cylindrical, tapering gently towards the tail. And make no mistake, they are truly formidable in size. Imagine a creature that can stretch out to an impressive length of up to 8 feet, or about 2.5 meters. To put that into perspective, that's roughly the height of a very tall person, or even a small car. And along with their considerable length, they possess a substantial weight, sometimes tipping the scales at as much as 44 pounds, or 20 kilograms. Their skin, rather than being covered in scales like most fish, is smooth and somewhat slimy, a dark gray or brownish hue along the top of their body, which helps them blend seamlessly into the shadowy, murky waters they inhabit. Their underside, in gentle contrast, often displays a softer yellowish-orange coloration, adding a touch of subtle vibrancy to their powerful form. Now here's where the story truly becomes electrifying, pun intended. An astonishing 80% of the electric eel's entire body, both by length and by weight, is dedicated to one singular, incredible purpose: the generation of truly prodigious, almost unbelievable, amounts of electricity. Think about that for a moment. The vast majority of this creature's physical being is a finely tuned, organic power plant, a living testament to the wonders of bioelectricity. Within this substantial portion of its body, running gracefully through its back section, the electric eel houses 3 distinct pairs of specialized electric organs. These are known, scientifically, as the sax organ, the hunter's organ, and the main organ. Each of these organs plays a crucial, yet slightly different, role in the eel's intricate electrical system. The main and hunter's organs are the heavy-duty powerhouses, responsible for producing the high-voltage discharges that the eel uses for its formidable defense and for stunning its prey. These are the organs that deliver those powerful, unmistakable jolts we discussed earlier. In contrast, the saxo's organ is a more subtle operator. It is capable only of producing low-voltage pulses, a gentle hum of electrical activity. Its primary purpose is not to stun or defend, but rather to facilitate electrocommunication and navigation within its dark and often opaque environment. It's like a finely tuned sonar system, or a secret language spoken in silent electrical whispers. But how, precisely, do these organs achieve such a remarkable feat? The secret lies within their microscopic structure. These organs are composed of hundreds of thousands of highly specialized, modified muscle cells, which scientists call electrocytes. Imagine these electrocytes as tiny, flattened, disc-like cells, meticulously stacked together. They are arranged in approximately 70 columns on each side of the fish's elongated body, creating a biological battery of immense complexity. And within each of these columns, a truly astonishing number of these tiny power cells are precisely aligned, anywhere from 5,000 to 10,000 individual electrocytes, all working in perfect synchronicity. Let's gently unravel the exquisite biological ballet that occurs within each of these electrocytes to generate an electrical charge. In their natural resting state, these flattened disc-like cells maintain a delicate negative charge across their membranes. This state is actively maintained by the cell, which tirelessly works to pump positively charged ions, specifically sodium and potassium, out of its interior. It's a constant microscopic effort, creating a subtle, invisible tension across the cell's boundary. Crucially, each individual electrocyte is intimately connected to the eel's nervous system. But here's an interesting detail. This connection occurs only on one side of the cell. This asymmetry is absolutely vital to the eel's electrical generating capabilities. Now imagine the moment an eel senses the subtle presence of potential prey, or perhaps the faint, distant tremor of a threat. In that instant, a signal, a tiny electrical message, is swiftly dispatched from the eel's brain, traveling along the nerve endings to these waiting electrocytes. Upon receiving this signal, a specific ion channel, a microscopic gateway on the side of the electrocyte connected to the nerve, springs open. With this gateway now unlatched, the extracellular positive ions, which had been so diligently pumped out, are now free to flow back into the cell, creating an immediate shift in electrical potential. Meanwhile, the opposite side of the electrocyte, the side without the nerve connection, continues its steady, rhythmic work, tirelessly pumping those positive ions out of the cell. This creates a fascinating and powerful imbalance. Suddenly, the side of the cell that received the nerve signal, the side where positive ions flooded in, becomes relatively positively charged. Conversely, the other side, still diligently expelling positive ions, remains relatively negatively charged. And just like that, with this exquisite dance of ions, voila, a dipole has been created. A minute electrical potential, a tiny voltage difference, now exists across that single electrocyte. This is the fundamental spark. From this point, the electric charge, now accumulating across countless electrocytes, flows harmoniously towards the eel's head, which acts as the more positively charged pole of its powerful body. From there, with incredible precision and force, this accumulated charge is then discharged through the surrounding water, arcing towards the intended prey. It's a stunning example of bioengineering, a symphony of cellular activity orchestrated to produce a powerful, directed flow of energy. The more these incredibly specialized cells are stacked one upon another, and the more they are precisely lined up in those columns, the greater the collective electricity they can generate. It's a principle of accumulation, where individual minute potentials combine to form a formidable whole. The truly incredible aspect, the silent marvel of this biological system, is that the eel possesses the capacity to open all of these thousands upon thousands of membrane gates, these tiny ion channels, at exactly the same precise moment. This synchronous, instantaneous opening is what allows for the creation of that singular, massive jolt of electricity, a concentrated burst of power unleashed with breathtaking speed and precision. While this ability to generate such powerful electrical discharges might seem like an extreme, almost otherworldly adaptation, it's actually rooted in the fundamental workings of what all typical muscle and nerve cells already do. Think about it. Every single muscle cell and every nerve cell within your own body and within virtually all living organisms, inherently possesses electrical potential. There's a subtle, constant electrical tension across their membranes, a readiness for action. When you simply contract a muscle in your arm, for instance, a small, almost imperceptible amount of voltage is released. The cells of an electric eel have simply taken this universal biological principle, this inherent electrical potential, and amplified it to an extraordinary degree, pushing the boundaries of what we might imagine a living creature could achieve. Indeed, the electric eel's astonishing ability to create electricity is often, and quite fittingly, compared to a battery. This comparison is not merely a convenient analogy, but a direct historical link, a testament to the profound influence of this creature on human ingenuity. The very first electric battery, an invention that would go on to revolutionize human society and usher in the modern age, was crafted in the year 1800, directly inspired by the living power of the electric eel itself. The brilliant mind behind this groundbreaking invention was an Italian physicist named Alessandro Volta. As he diligently pursued his scientific inquiries, Volta became deeply fascinated by the reports and observations of the electric eel. He noted with keen scientific insight that these electrifying fish contained intricate stacks of specialized cells, an arrangement that to his discerning eye resembled nothing so much as a neat roll of stacked coins. A spark of genius ignited in his mind. He reasoned that if he could somehow mimic this natural stacked arrangement using inanimate materials, he too might be able to generate a continuous flow of electricity. Driven by this elegant hypothesis, Volta embarked on a series of meticulous experiments. He carefully cut coin-shaped discs from various dissimilar metals, experimenting with different combinations, patiently stacking them one upon another. His objective was to discover any pairing of these metallic discs that, when brought into close proximity, would be capable of generating an electrical current. After countless trials and careful observations, he finally hit upon a winning combination, discs of copper and zinc. He then innovatively separated each stacked pair of these metallic discs with pieces of cardboard or cloth that had been thoroughly soaked in salt water, acting as an electrolyte. And lo and behold, to his profound satisfaction and the astonishment of the scientific community, electricity began to flow. This ingenious arrangement of stacked metal discs, separated by a conductive solution, came to be known as the voltaic stack. It was a revolutionary invention, truly deserving of its place in history as the very first electric battery ever made. Before Volta's groundbreaking discovery, scientists possessed only a rudimentary understanding of static electricity, observing its fleeting presence in phenomena like lightning or the crackle of rubbed amber. The electric eel, with its living, flowing current, had provided the crucial key, unlocking a deeper comprehension of this fundamental force. And in doing so, it was only just beginning to reveal its vast and intricate mysteries to an eager scientific world. As researchers continued to study these remarkable creatures, they quickly came to understand that electric eels do not adhere to a simplistic one-size-fits-all policy when it comes to their electrical discharges. Instead, with astonishing biological finesse, they are capable of utilizing different charges for a diverse array of purposes. Some of these electrical emissions are subtle, designed for sensing their environment, like a living radar system. Others serve as a form of silent electric communication, allowing eels to interact with one another in their dark, watery world. And of course, there are the powerful high-voltage discharges, specifically tailored for stunning their prey, and even, as we've begun to discover, for subtly controlling the movements of those very prey animals. The electric eel, in essence, wields its electrical power with a truly remarkable degree of precision and control. Let's delve into the fascinating ways an electric eel interacts with its environment using this intricate electrical system, Imagine the murky, often impenetrable habitats where these eels make their homes, streams choked with vegetation, floodplains rendered opaque by sediment, and swamps where sunlight struggles to penetrate. In such an environment, the sense of sight, so crucial for many predators, is largely diminished. Indeed, the electric eel's eyesight is known to be extremely poor, almost an afterthought in its sensory repertoire. So, how does it navigate this world of shadows and hidden obstacles? It relies on a remarkable ability called electrolocation. To achieve this, the eel emits a constant, low-voltage electric discharge, typically around 10 volts. This weak electrical field emanates outwards from its body, gently permeating the surrounding water. As this subtle field interacts with objects in its path, a submerged log, a rock, another fish, it creates minute distortions, tiny ripples in the electric field. Some objects will conduct electricity more readily, while others will resist it. The eel, with its exquisitely sensitive electroreceptors, is able. And then, of course, there is the primary, most dramatic application of the eel's electrical power: its prowess as a hunter. Electric eels are predominantly nocturnal creatures of the twilight and the dark. As night descends upon the Amazon, blanketing the rivers in shadow, the eel awakens to its hunt. It will patiently wait for the deepest hours of darkness, then silently, stealthily, it will maneuver itself closer to its unsuspecting prey. With a sudden, explosive burst of energy, it unleashes a rapid series of high-frequency, high-voltage pulses. Imagine this moment, if you will, without any sense of alarm, but rather with a quiet appreciation for the raw power of nature. In scientific observations, these moments of discharge are sometimes highlighted in videos, where red frames flash, momentarily illuminating the scene, indicating precisely when the electric organs are discharging their potent energy. After just a few fleeting milliseconds, an almost imperceptible fraction of a second, the prey, caught in the invisible grip of the electrical field, becomes completely immobilized. Such a high-frequency, high-voltage attack induces massive, involuntary, whole-body muscle contractions in the prey fish. The sudden surge of electricity causes the prey fish's motor neurons, the nerve cells that control muscle movement, and consequently, their muscles themselves, to become simultaneously activated, firing all at once in an uncontrollable spasm. The higher the voltage delivered, the more intense and violent these muscle contractions become. At the peak of its power, at 600 volts or more, these attacks often trigger the maximum possible muscle contraction, causing the unfortunate animal to completely seize up, locked in an unyielding grip. It's a mechanism strikingly similar to how a taser device works, delivering a sudden, incapacitating burst of electrical energy. Once its prey is rendered motionless and helpless, the eel can then proceed with its quiet feast. Interestingly, electric eels do not possess upper teeth, a detail that further highlights their reliance on their electrical powers. Instead, they employ a powerful suction mechanism, creating a sudden vacuum to pull their stunned prey swiftly into their mouth before swallowing it whole. A silent, efficient process carried out in the dark, flowing waters. For a considerable period, scientists believed that electric eels operated with a straightforward two-tiered electrical system. The low-voltage discharges for the crucial tasks of navigation and communication, and the potent, high-voltage discharges exclusively for the immobilization of their prey. This seemed like a clear and logical division of labor for their electrical talents. However, as is so often the case in the boundless tapestry of the natural world, further dedicated observation soon revealed that there was, in fact, much more to the story. It became clear that eels were employing their electricity in even more cunning and sophisticated ways. demonstrating an astonishing adaptability that continued to surprise and inspire researchers. A pivotal moment in this deeper understanding came when scientists began to meticulously examine the precise timing and patterns of the electric pulses emitted by the eels. It was during these careful observations that an intriguing pattern began to emerge, a subtle anomaly that hinted at a more complex predatory strategy. Researchers noted a particular sequence, almost a prelude to the main attack. They described how the introduction of prey into the aquarium arouses the eel, causing it to swim around, but often stopping in a particular corner of the aquarium. During these stops, two high-voltage pulses with an interval of about 2 ms are emitted. This was a specific, almost ritualistic behavior, a pair of quick, powerful bursts that preceded the full, immobilizing volley. These two initial high-voltage pulses quickly became known as doublets, and at first their exact purpose remained shrouded in mystery. Why would the eel expend energy on these two quick pulses initially, especially when its subsequent massive attack volley was more than sufficient to completely immobilize its prey? It seemed like an unnecessary preliminary step, a question mark in the eel's otherwise efficient hunting repertoire. To unravel this enigma, scientists embarked on a series of carefully designed experiments, meticulously observing the eel's behavior with great patience and precision. Through these focused observations, a few crucial details began to emerge. Firstly, they consistently noticed that a full, massive attack volley, the kind that completely immobilizes prey, would almost invariably follow these initial doublets. The doublets, it seemed, were a clear precursor to the main event. Secondly, and perhaps more tellingly, the doublets themselves, these two quick bursts of electricity, consistently resulted in a distinctive whole-body twitch in any nearby fish. It was a subtle, yet unmistakable, reaction, a sudden, involuntary spasm. These observations sparked a compelling hypothesis in the minds of the researchers. Perhaps the primary purpose of these enigmatic doublets was not to stun the prey directly, but rather to serve a more cunning, indirect function. Perhaps, just perhaps, these initial pulses were designed to force the prey to reveal its hidden location to the eel. In the murky waters where vision is limited, a sudden, involuntary twitch would create subtle water displacements, disturbances that the eel, with its exquisite sensory capabilities, could instantly detect. It was a brilliant silent strategy for target acquisition. To rigorously test this innovative hypothesis, the scientists devised a truly clever and elegant experiment. Picture a carefully controlled aquarium environment. On one side of a porous agar barrier, designed to allow electrical currents to pass through while physically separating the subjects, they gently placed an electric eel. On the opposite side of this barrier, they positioned a dead fish. To ensure precise control over the experiment, this dead fish was connected to an external electrical stimulator. Importantly, the fish itself was sealed within a bag, effectively isolating it electrically from the eel. This ingenious setup meant that the scientists could electrically jolt the dead fish with their stimulator, mimicking the effect of a shock. But the live eel itself could not directly apply a shock to the isolated fish. The stimulator was then calibrated and set up so that whenever the live eel emitted one of its characteristic doublets, it would simultaneously send a similar, precisely timed shock to the dead fish, causing it to twitch. The results of this experiment were truly illuminating. When the live eel emitted its doublet, and the dead fish in response received the simulated doublet from the stimulator, causing it to twitch, the eels immediately reacted. They would swiftly respond to this telltale twitch with their full high-voltage volley, launching a direct strike towards the now revealed dead fish. The sequence was clear: doublet, twitch, full attack. However, when the investigators meticulously turned off the stimulator, breaking the connection that caused the dead fish to twitch. A different outcome unfolded. In these instances, even when the live eel emitted its doublet, no twitch was produced in the dead fish, and crucially, without that involuntary movement from the dead fish, the eel did not follow up with its powerful attack. The eel, it became evident, would only commit to a full attack on the fish if it first twitched in direct response to its own emitted doublet. This groundbreaking study provided compelling evidence that electric eels are indeed capable of remotely controlling their prey, literally forcing them to betray their location. The doublet, far from being a superfluous preliminary pulse, functions as an ingenious biological question. Are there any fish out there I can eat? And in the murky, silent depths, the unsuspecting prey, caught in the invisible electrical web, has no choice but to respond, its involuntary twitch serving as a silent beacon, guiding the eel to its meal. It's a remarkable display of biological sophistication and predatory cunning, revealing a depth of intelligence in these creatures that continues to captivate and astound. But what happens when an electric eel finds itself in the proximity of an entire shoal of fish, a dense, teeming collection of potential prey? And what if this shoal, perhaps through evolutionary adaptation or collective vigilance, proves particularly adept at maintaining its distance, skillfully avoiding the perilous range of the eel's potent shocks? To contend with such a challenge, some electric eels display an even more remarkable behavior, a strategy that was once believed to be practically unheard of in the entire world of electric fish. This is the phenomenon of social predation. Social predation, a sophisticated hunting tactic, where groups of animals coordinate their efforts to hunt and kill prey, is a behavior that is quite commonly observed among various mammal species. Think of the intelligent, cooperative hunts of wolves, working in concert to bring down larger prey, or the intricate strategies employed by orcas, the majestic predators of the ocean, as they herd seals or other marine life. Even the powerful lions of the African savannas demonstrate remarkable teamwork in their pursuit of food. However, in the vast and diverse world of fish, such cooperative hunting behavior, particularly at this scale and complexity, is almost entirely unprecedented, a truly rare and astonishing sight. It was during their patient scientific travels through the sprawling, life-filled arteries of the Amazon River that scientists made a discovery that left them almost in disbelief. They began to observe groups of electric eels, sometimes numbering over 100 individuals, seemingly congregating, coordinating, and working together to round up and attack their prey. This was not a random gathering. It was a synchronized effort, a collective display of power that had rarely, if ever, been witnessed in fish before. And these were not just any electric eels. These were volta eels, a species known to be among the most powerful of all electric eels, capable of delivering individual shocks of up to 860 volts. The idea of such formidable creatures with their immense power working in concert was truly a marvel to behold. The scientists, with their calm and careful observations, noted that as dawn began to softly break, and again as dusk gently settled over the river, there was a noticeable increase in eel activity. Many individual eels, which had perhaps been resting in the murkier depths, would begin to leave their shadowy havens, swimming gracefully towards the surface. Here they would appear to deliberately congregate, forming loose but distinct groups. These nascent groups of eels would then begin to swim together with a clear sense of purpose towards specific shallow hunting areas known to contain vast numbers of small fish, sometimes thousands upon thousands. Once they reached these designated hunting grounds, these groups, sometimes comprised of 100 or more individual eels, would initiate a coordinated maneuver. They would begin to swim in slow, deliberate circles, an ancient instinctual dance designed to herd the myriad small fish. This circling motion would gradually compress the fish into tightly packed prey balls, dense swirling masses of frantic fish. With relentless synchronized persistence, the eels would then gently but firmly push these vulnerable prey balls into even shallower waters, effectively trapping them and making them easier targets. Then, with an astounding display of coordinated action, a smaller subset of the group, typically between 2 to 10 individual eels, would launch a joint predatory strike. In observing this, one might notice the attacking eels, distinguished by their synchronized, graceful sinusoidal body posture, a rhythmic wave-like movement as they unleashed their combined electrical might. The fish caught within this devastating electrical attack would spasm so violently, with such intense involuntary contractions, that they would often leap clear out of the water, a chaotic ballet of desperation. Upon falling back into the water, they would be stunned and motionless, floating lifelessly on the surface. It was at this opportune moment that the waiting eels would swiftly move in, consuming the incapacitated fish. This intricate sequence of attack would be carried out repeatedly, sometimes 5 to 7 times within a single hunting session, and with each successive attack, a different subset of eels from the larger group would step forward, taking their turn to produce the powerful electrical discharge. It was a rotating responsibility, a division of labor that speaks to a sophisticated level of social organization. Although the researchers, due to the challenging nature of fieldwork in the Amazon, were not able to directly measure the precise voltage of these coordinated electric attacks, they were able to make educated estimates. They surmised that a group of just 10 volters electric eels, working together in such perfect synchronicity, could collectively generate an astonishing 8,600 volts. Imagine the sheer raw power of such a collective discharge, an invisible force capable of overwhelming vast numbers of prey. This remarkable hunting technique, this collective electrical assault, allows the eels to effectively subdue and capture huge quantities of prey that would, under normal circumstances, be far too evasive and scattered for a solitary eel to ever hope to catch. And this isn't simply a case of eels being inadvertently stuck together in a confined space, forcing them to feed on the same available groups of fish. No, the observations indicated something far more intentional and sophisticated. These eels were actively congregating from far and wide, traveling significant distances to repeatedly forage together over extended periods of time. Their coordination was facilitated by a subtle yet effective combination of communication methods, utilizing their low-voltage electric pulses to send signals to one another, and employing distinct body posturing to convey intentions and coordinate actions. It was a silent electrical language of the hunt. One question that naturally arises in our understanding of such complex social behavior is whether these eels have any familial relationship to one another, similar to what is commonly observed in many other pack hunters like wolves or lions, where kinship often underpins cooperative efforts. At present, this remains an unknown, an intriguing mystery that scientists are actively working to unravel. However, what is already clear is the rarity and significance of this discovery. Only 9 other species of fish have ever been observed to hunt together in such a coordinated fashion, and among them the electric eel's tactics, with their unique electrical component, may well be the most formidable and innovative. This groundbreaking revelation reminds us that animals we thought we understood, creatures whose behaviors we believed were neatly categorized, can often harbor more than one survival strategy. It teaches us that in isolated regions and specific groups of animals, the intricate dance of predator-prey interactions may not be at all what we expect, constantly challenging our assumptions and expanding our understanding of life itself. As we gently drift through the depths of these fascinating discoveries, a lingering question might naturally settle into your mind, a quiet curiosity that arises when contemplating these electrifying creatures. How is it that the eels themselves do not suffer from their own formidable shocks, or perhaps more puzzlingly, from the powerful discharges of their fellow eels during a synchronized hunt? Let's first address how an individual eel manages its own internal electrical powerhouse. It is widely believed that the electric organs of an electric eel are thoughtfully padded with a generous layer of adipose tissue, a specialized fatty tissue. This adipose tissue acts as a natural insulator, a protective barrier that effectively shields the fish's vital organs and its own nervous system from the very electric shock it generates. It's a brilliant example of self-preservation through biological design, ensuring that the living power plant doesn't inadvertently short-circuit itself. But what about the more complex scenario, the one we just explored with the pack hunting? How do these eels prevent themselves from receiving a debilitating shock from other eels during a coordinated attack, where multiple individuals are unleashing hundreds of volts into the shared watery medium? The likely answer, in its elegant simplicity, is that they don't entirely prevent it. It's probable that electric eels do indeed experience the electrical discharges of their conspecifics. To understand why this isn't a catastrophic event for them, we need to consider their size. Electric eels are, as we've noted, quite huge, much larger and more robust than the small fish that constitute their primary prey. This significant difference in size is likely a crucial factor. While an eel's powerful current will easily incapacitate and overwhelm its much smaller target, it won't have the same devastating effect on its own larger, more resilient body. You can compare it, perhaps, to the way a single electric eel shock to a human, while certainly painful and startling for a moment, would not typically kill us. We are simply too large, and our physiological systems are robust enough to withstand it. In a similar vein, for an electric eel, navigating a world filled with its own kind, where powerful electrical discharges are commonplace, getting shocked is likely just an accepted, perhaps even routine, part of doing business. It's a calculated risk, a sensory input, that their biology is well equipped to handle, allowing them to continue their remarkable lives and their synchronized hunts in the electrifying currents of the Amazon. As we gently draw our story to a close, let's reflect on the profound connection between the world of the electric eel and our own. For this remarkable creature, its entire existence, its very survival, profoundly revolves around its extraordinary electrical capabilities, and in a wonderfully reciprocal way, largely thanks to the insights gleaned from the electric eel, so too does much of our modern world. Consider the simple yet profound act of charging your phone, or the quiet moment when you slide fresh AA batteries into your remote control. In these everyday actions, in the silent hum of power that permeates our lives, you can find a subtle yet direct lineage stretching back to the humble, powerful electric eel. Its biological blueprint provided the fundamental inspiration, the spark for our initial understanding of continuous electricity and the invention of the battery, an invention that literally illuminated our world and powered our progress. And the story doesn't end there. We continue to be inspired by these living wonders. In laboratories around the world, brilliant researchers are currently working on developing an entirely new type of battery, one that is directly inspired by the elegant, flexible, and biocompatible design of the eel's electric organs. Imagine a soft and flexible battery, a revolutionary power source that could safely and efficiently power delicate medical implants within the human body, or provide the silent energy for the next generation of soft robots, designed to interact gently with their environment. These are just some of the futuristic applications that owe their conceptual roots to the ancient power source found deep within the Amazon. It seems clear that we are likely just beginning to truly understand these incredible creatures, these living marvels of bioelectricity. Many more of their mysteries, their silent adaptations, and their ingenious strategies still undoubtedly lurk in the muddy, shadowy waters of the Amazon, patiently waiting to be discovered, to further expand our awe and understanding of the natural world. As you prepare to drift deeper into rest, allow your mind to gently consider the silent, invisible power of electricity that surrounds us every day. It's a force so ubiquitous, so seamlessly integrated into the fabric of our modern lives, that it's nearly impossible not to take it for granted. Perhaps, like many of us, you don't often pause to think about the intricate pathways that bring light to your kitchen, or the unseen energy that keeps your computer humming, ready for another day. It's a silent, constant presence that underpins so much of our comfort and convenience. But the more we learn about its origins, its manifestations in the natural world, the more incredible and mysterious it truly becomes. The story of the electric eel is a testament to the elegant ingenuity of life, a reminder that some of the most profound scientific breakthroughs have emerged from a patient observation of the natural world, from simply paying close attention to the wonders that exist all around us. Let this gentle narrative, this quiet exploration of ancient power and modern discovery, slowly dissolve into the peaceful currents of your own thoughts. Allow the images of the Amazon, the silent glide of the eel, the dance of ions, and the quiet spark of inspiration to simply float away, leaving you with a sense of calm and wonder. Now,